Okay, so back in 11.10, some of these questions they ask you find the sum of the series. Now, if you're looking for the sum of the series, there, like I told you earlier, you can find the sum of very few series. All right, so we have to go off of something that we already know. When I look at this, I see an exponential along with a factorial paired in. So when I see that, I think, this kind of looks like e to the x. How do I mean? Remember, e to the x, this is that power series. You're looking at your list to see if this matches anything you've got, right? This is 0 to infinity, x to the n over n factorial. So how do I make that look like e to the x? Okay, well, I've got something to the n, right? This is really like 3 over 5 to the n over n factorial. Sum n equals 0 to infinity. So what does this equal? What does this sum to? This sums to e to the 3/5. Why does it sum to that? Because we know that this is true for all x. Okay, we found this in an earlier example, but it's found by the ratio test, right? Ratio test. Okay, we run through the test. We set it less than 1. By the way, it is less than 1. It limits to 0. So it works for any x value we can think of. Pretty interesting idea that we can take particular series, right, and then look at it and figure what does it actually sum up to exactly, right? So maybe I didn't plan this, but maybe we can like play around here and see if we can make up some other ones, right? So let me just use our little list here, okay, and maybe we can make some other ones up. So maybe like I want to make up one with the sign, okay? So maybe I have a series n equals 0 to infinity, -1 to the n, and then maybe I have I don't know, i'm just gonna throw something in there. Maybe it's like pi over 2n plus 1 over 2n plus 1 factorial. Okay, so you see something like that, you say, oh man, I see the 2n plus 1, I see the 2n plus 1 factorial. I'm thinking, okay, well, interval of convergence here for sine works for all x. So for all x here, just like it was for e to the x, and cosine x is the same way. This is going to be the sine of pi over 2. So this series, looks rather complicated, but it actually sums to 1, which is pretty amazing. Okay, so like if I did some algebra simplification here, maybe I can rewrite this. Let's see here. Let's see what we can play around with. I'm just playing around. I'm just having some fun. Pi over 2 to the 2n. If I was going to write out a test question, this would be kind of how I would do it. If I'm just making one up, I start with the answer and I just work backwards. So now you kind of get to see how the sausage is made, right? So behind the scenes factory working right here, okay? So, and then I'd think, okay, well, that's cool, but, maybe I can make this a little bit more hidden. What if I change this to be, I don't know, if I was really going to be a meanie, I can leave this right here. This is fine. But what if I did this? Like I had my pi over 2, right, from right there. But then it did like pi squared. Okay, let's see. Can I do this? So pi squared n over what? 2 squared n? Okay, let's see what we got going on here. Can can I write this out? And that's going to be, so what if I wrote it like this? So 0 to infinity, -1 to the n, and then, I put pi to the 2n plus 1 over, and what if I did like 2 and then times 4 to the n, right? I can do that. That's okay. And really, like 2 is like 4 to the 1/2, right? So look, oh, this is good. Oh, this is really cool. Okay, so I'm going to turn that 2 into 4 to the 1/2 and combine it here. Look how sneaky I am. Do you see this? Look at that. I am making your life terrible. Yeah. All right. So you see how you can get pretty sneaky here, but you still see some flavor of something raised to the 2n plus 1 over 2n plus 1 factorial. When I see that, I should start thinking, Mr. Clark is sneaky, but I know when I see this, I should think a power series. I should think some Maclaurin series with sine x. And then I go to that formula and see if I can't find it. Okay? So that's kind of how I want you to be thinking about those sums, right? Let me run through with this one, because this one's kind of interesting to me. So ln x equals series 1 to infinity, -1 to the n plus 1, x minus 1 to the n over n, right? So this one's an interesting one. Let me do with x equal to 2. This would be interesting. So the natural log of 2 is what? N equal 1 to infinity, -1 to the n plus 1. If I plug a 2 in here, that's 2 minus 1, which is 1 to the n, over n, okay? So 1 to the n, right? 1 to the n is just 1, so that goes away. So what do I have here? I have the series from 1 to infinity of -1 to the n plus 1 over n. Oh my goodness, does this look familiar? Y'all know what this is? This is the alternating harmonic. Wow, that's the alternating harmonic series. Now, do you remember this thing right here converges conditionally only, right? When we took the absolute value, we got the sum 1 over n, and this thing diverged by the p series, right? So that diverges for absolute convergence, but if I use the alternating series test, since it's decreasing and the limit is going to 0 at the sequence an goes to 0, then by the alternating series test it converges conditionally, right? Okay, so when a series converges conditionally, remember we can add the terms up in any way we want, and we could get any number we wanted, right? Now this one in particular, if we add it up in the right order, okay, we add it up, starting at n equal 1, we get 1 over 1, and then what do we get? Minus 1 over 2, plus 1 over 3, minus 1 over 4, plus 1 over 5. If we add it up in this order, we get ln2, right? But do you remember whenever we started swapping around the orders, we could add it up to any number that we wanted to add up to? Well, that is a property of conditional convergence, okay? So that's interesting there too. So if I gave you this series, you could tell me what it summed up to, and maybe I'll throw that in on a test. Who knows? We'll see. It just depends on how mean I want to be, right? But definitely be looking at this list right here, and if you can't find it, I think in your textbook, maybe it's like page 808 or something, like page 808 maybe. So it just depends from textbook to textbook, right? So you can look for the list there if you want to. Okay, but that's enough of showing you, you know, how teachers think, right? How they make up their own problems. All right, guys, good luck with your homework and trying to figure out how to find the sum of the actual series, not just trying to figure out does it converge or diverge.